Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Mads and Rustam, who will be presenting on the topic of serverless Java app in the cloud, MicroProfile, Quarkus, and Cloud Run. If you have any questions for Mads and Rustam as we move through today's presentation, feel free to ask them in the chat or use the Ask a Questions tab. Without any further delay, Mads, Rustam, over to you.
Thank you very much. Thank you for having us. It's great to be back and great to be here today with you all. Good morning, good evening, good afternoon, depending on where you are around the globe. And it's I'm happy to be here. Mats?
Yeah, this is going to be fun. So before we start talking about Java app development in the cloud, which we're going to do for like the next hours. And hours, sorry, not hours, but single hours. No worries. So for the next hour, we'll be talking about modern Java app development in the cloud. And the two of us who are going to talk about that is me. My name is Mats Opheim. I work in a Norwegian consultancy company. It's called Kompetas, where I do mainly Kotlin nowadays, but I've been doing Java for many years. And yeah, I'm an Oracle ace. And in Java. Love Java. We'll be talking a lot about that. Who are you, Rustam?
My name is Rustam. I am a developer architect in the same company as Mats. So we work as a consultant mostly with Java, with cloud and that kind of stuff. So I'm also Java champion, Google developer expert for cloud, Oracle ace, all those things. And I work and talk mostly about cloud and Java in one way or another. Sometimes both, sometimes one of them, and sometimes it's a mix, and sometimes it's not. So that is a short introduction about us. And let's talk now about what we're actually going to be talking about. Because, if I ask how many of you write code, it will be the majority of you. But the question is usually that is kind of fun. Is like, why do we actually write code? Because we write code to, well, obviously it's fun and we enjoy doing that and all that. At least most of us are doing that. I assume. Now I'm assuming things, but sorry if I'm wrong, but it's, at least it is like that for me. But the idea is like we write code to solve typically a problem, right? We just do it because we need to solve something. And usually that something needs to be available to other people. And today we're going to be talking about how you actually take that piece of code that you've written and make it available to as many people as possible, and to make it available also to in a manner that is a more cloud native and modern way of doing that, and also hopefully not too expensive way of doing that when you think about billing and all that. So the main story is we have some piece of code. We want to put that thing into production, like I said, right? And anything else we want to say here, or should we show our application? Super advanced, very, very difficult, hard to grasp application.
Yeah, I think we can mention like one of the goals, like overall goals for this talk is that we're not really really interested in like infrastructure and so on. I want to do like git commit, git push, and then I want everything to happen, and then I want my code to be in production. Exactly. That's like the underlying idea for this talk, is to put us into that place.
So we kind of want to think about all these modern ways of saying that. Sometimes it's being called DevOps way of thinking and all this kind of stuff. But the idea is that you actually have to do both development and ops of your code and all that. But you want to automate things as much as possible, so you don't really have to think about all those steps. You just write code, push it, and it's available. And our application is quite on purpose. And well, actually, one more thing before we do that. One more thing is that this talk will be opinionated, because obviously we had to choose some products that to make that code available. But a lot of those things that we'll be talking about can also be applied to other products, frameworks, all the other kind of things. But this will be a slightly opinionated. We had to pick some things to actually build application. So the application, it is a very simple application. It just gives you back two random words from two different dictionaries, so typically an adjective and a noun, that will provide you with, every time you call an API, it will give you a list of two words. One will be a noun and the other one will be adjective. So like something like this. So, well, it's well, that's what you get, right? Sometimes you can use it. I mean, this was a little bit inspired by two-factor authentication systems that we have here in Norway. Sometimes you would just like try to log into something like your bank or anything to show you two words like this, and then you'll get the same words on your mobile phone, and then you will know that it was actually the application on the screen that initiated that thing on your screen, on your phone, and all this kind of stuff to make it more secure. You've seen something similar to this, and also probably if you've been creating a lot of containers. I know that some container applications also give names to containers. You can don't specify that. Also in the same way, just noun and adjective. You can probably use that. I've been suggesting it a couple of times now that you should probably try to use that for naming your pets, but somehow it didn't really get that much traction yet. So maybe somebody will start using that for this. I don't know. But you know, let's stick to containers, naming containers now. And you refresh that again, it will give you another set of words. And well, should we talk a little bit about the logic? So logic is very complicated.
Yeah, so it's like you can see the logic of the application is like 3 lines of code. Of course, there are some method calls here and so on, but you can see the logic is like, well, read the list of adjectives, get a random one of those. The same with nouns. So that's it. Just to have something to show you.
So this is a typical piece of, a method that you create, right? But then we all learn to, okay, now we need to make that thing, that method is there, but you can't really run that method this way, right? In Java, you will need to at least add some kind of main method or something like that, or, but if you run it with public static void main, all this, it will run on your machine. But, remember I told you that the whole idea was to try to make it, or actually to make it available to people around the world, or to make it available for more than just yourself. So this public static void main thing, that doesn't really fly really well with this kind of requirement. So we need to run it somehow. And if you look back at the URL and also at the screen that you've seen a little bit earlier, you see that there is a little bit of giveaway. Like, how do you want to do that? And
yeah. I guess some of you recognize that the array down here might be a JSON array, and that the /API that might be an API call using REST, or at least HTTP. So. And you were right.
And also, that the one thing is that we kind of see here, it's that, well, at least we're going to refer to later. Just, I mean, for now it's a local host, but we'll do something about that later as well. So a little bit of spoiler alert for now. But the point is, it will be a URL, and that's how you want to make it available. To do that, we needed to choose something. So we decided to go with whatever Jakarta EE has to offer, and also whatever we have to, whatever can make it simpler for us to build REST interfaces and all that. And that was also where Jakarta so Eclipse Foundation, another project from Eclipse Foundation, comes into the place. That's the MicroProfile. So that's a kind of those two, a mix of those two. That's what we decided to use to build that application. And before we go any further, maybe we should just mention really quick. I don't know how many of you. I mean, you can feel free to use the chat to ask questions, comment, and say things, whatever you would like to share with everyone else. And also, please share if you have used MicroProfile before as well. So that would be really nice. But while you do that, I think we can talk a little bit more about what is that thing really quick. What is it? What is that thing?
Yeah, let's do that. So one easy way to put it, which is, it's not true, but it's a useful model, is to say that, well, MicroProfile is the microservices. It's Jakarta EE for microservices.
Mm-hmm.
So you can say that while Jakarta EE has a lot of different features, as we'll see in a moment, with MicroProfile you get a set of specifications that are suitable for microservices, really opinionated ones. So we'll see that in a minute. But first, let's see that. I assume that lots of you know what Jakarta EE is, since after all, this is Jakarta Tech Talks, so this might be a place where people know Jakarta EE, but still, there's a lot of features and aspects of Jakarta EE, so I think we should spend a couple of minutes going through some of it anyway, so that we're on the same page and same level when talking about Jakarta EE. So as we can see on the next slide, here, you see that Jakarta EE version 10 is the newest one. So you can see that it's a platform, and you can see in gray behind it, you can see Jakarta EE web profile, and you see lots of boxes. But to the right, you can see the Jakarta EE 10 core profile. And each of these boxes represent a specification. So to try to put it easily, it's like something you typically need in many business applications is one of these boxes. So things like, you need to send mail, for instance, that Jakarta mail, or you need to do some authorization, or even some persistence. Like, these are typical things you need in big applications. And there are different profiles. So in this talk, we're going to focus on Jakarta EE 10 core profile, which is new in 10. And that's dependency injection, it's JSON and REST. So those things we've already seen. And what's so special about the core profile is that, yes, it is part of Jakarta EE 10. So it's part of Jakarta EE, but it's also crucial for MicroProfile. Crucial part of MicroProfile, actually, as we see on this slide. And here is like, you can see on the bottom to the left, it's MicroProfile, the MicroProfile umbrella, so to say. And what you can see at the bottom is Jakarta EE 10 core profile. So you can visualize it in a way that MicroProfile builds upon Jakarta core profile. And like everything uses CDI and everything is REST-based and so on. And you can see that there are many specifications here. So 6.0 is the newest MicroProfile release. That's why it says 2022 at the top. So we're looking forward to the next one. But I think what we really should say here is that we can see that in Jakarta EE, you have things like, you can do things like with JAX-VL, with Jakarta Web Services and REST services, whereas MicroProfile just says REST. So it's even more opinionated in a sense.
And before, it used to be all those boxes that you've seen in the part of the core profile. It used to be like separate boxes and all that. Now we had this change where we kind of have a separation of Jakarta EE profiles, and now we have that as a kind of foundation for all those things on top of that. And then it adds more things that are typically needed for microservices that will typically your microservice or generally your cloud native applications. There is also a term called like modernization of app modernization and stuff like that. And those kind of apps typically will need those boxes that you see on top of Jakarta EE core profile that's on the bottom there. You would need to have, you need to expose metrics of your microservice, or you need to have some kind of way of authenticating your users or your calls, or you need to expose some health information. Maybe you need to create a REST clients to talk to other web-based REST-based services or RESTful services, configuration, fault tolerance, all those kind of things. And then there is also things on the side that we're not going to talk too much about, but They're also part of this umbrella thing, but not of the main MicroProfile part. It's all about things like reactive and GraphQL and all those kind of things. But let's talk a little bit more about who's behind this thing. So there's a working group that is actually decides how things should look like in MicroProfile and what should be there and what shouldn't be there and things like that. And here you can see it's a mix of big names, big companies, and also smaller ones. Also some of the companies that you may not have seen they're big in, for instance, in Asian part of the world and not that known in the other outside of that area. But then you also see the top line, which is JUGs, Java user groups, that are also part of the working group where they support and put in some work as well from the community side as well. So Atlanta JUG on top there, iJUG, that is a kind of umbrella user group, Java user group for Germany, and also Garden State Java user group, which is, Garden State, that's New Jersey, so US based as well. Right. Let's mention also companies that, it is implementations of MicroProfile, right? You want to do that? Yeah, do that. Go ahead.
Yeah, sure. And I think we should start this slide by repeating something I said without explaining it earlier. Is that MicroProfile is a set of specifications. That means that, MicroProfile specifies to do health, you do it this way, and then someone needs to actually take that and implement it into code. And typically, app servers or application runtimes implement the entire MicroProfile, or at least most of it. So these are examples of application servers that implement MicroProfile and Jakarta EE as well, which is really nice. And you can see big companies like OpenLiberty from IBM, Wildfly and Quarkus from Red Hat, Helidon from Oracle, but also Cumulus, which is a smaller Slovenian company, or Tommy from Apache. So there are different app servers. And what is really cool here is that if you write your code using MicroProfile and Jakarta EE, and you start out with one of these, and you realize that, I should really switch to the other app server because of this and that, then you can do that without changing the code at all. It's really cool. We might say more about that later on. And all these app servers have their own strengths and weaknesses, of course.
Yeah, and we'll probably mention a little bit of that. I mean, not exactly like going through all of those, but we're going to probably talk a little bit more about that during this presentation as well. But I mean, okay, we talked about all this, and we're still in the situation where we have a little method that we don't know where to put. I mean, we put in public static void main to it. It runs on our machine, everything fine, but when you want to share it with the world. So where do we start? How do we actually start this Jakarta EE MicroProfile thing? And it's also probably a question, if you haven't used that, if you haven't created this kind of applications before yourself, so you probably would like to know that as well. So there are different starters. So it all started with one, and then all the other providers started to create their own starters for their own application servers, or actually runtimes, because some of them would like to be called that. So, you can basically either you can choose the one you want to go with and just generate it there, or you can generate it one, and then you can actually modify the POM files or Grader files or whatever you're using to build your application to contain all that information. But probably good idea is to pick one of those starters. So in our examples, we'll be using actually quite a bit of OpenLiberty and Quarkus. So, we ended up using one of those, but there is nothing wrong with, or actually you're more than welcome to pick any other provider as well. So, go ahead.
Yeah, sorry. No, but just think we need to add that, well, if you download one of these starters, you typically get examples of this is how you do create a REST endpoint in this with this runtime, and this is how you do JSON, and like it's easy for you to take the code that we've shown you and put it into the starter and tweak it to your needs. It's pretty cool. Of course, also you can download the starter and then copy the files into an existing project you have if you want to.
Or if you want to switch between projects, between the runtimes, you can actually do the same thing. You just download the artifact of the whole starter thing, and you just move the files that you want to. Typically, I mean, we're going to be using Maven in this example, in this project, and so that also means that we kind of work with POM files, POM XML files, and it also means that, you know, if you want to switch from Quarkus to OpenLiberty, or from OpenLiberty to Quarkus, or to Helidon or whatever, we'll just download those artifacts and just copy the POM files and replace them, or maybe just annotate them with different names for different application servers, and just will work. Okay, so now we kind of make sure that it works on our machine, and it also works not just with public static void main, but is also running now on the local host as a application. So we can actually go download that artifact from whatever starter that you've chosen. You put that method that pick two random words thing into that application that you have, example application that you have there, and typically it will tell you what to do, how to run that application server. So some of them would have like a dev mode that you can start that will refresh all changes and all that. Some of them you can just do it as simple as do Maven clean. So you basically build the whole thing, and then you just run it as a fat jar, for example, right? And it still works, and you can make it run. And it's typically it would be a jar file that can be run with like Java dash jar, and then the jar name. But we're still not there. We're still not into the all cloud native thing, right? So the next step would be to put it into something that can be portable. I want to talk a little bit more about that.
Yeah, sure. So this is probably not a surprise for many of you. Like containers is kind of like a default way of doing things nowadays. But what's really nice about containers is that, well, and the entire idea behind it, right, is like when we used to build applications and say like, well, it works on my machine, then the idea is like, okay, take your machine, put it together and ship it. So standardize it in a sense. That means that you can have the exact same code running on the exact same artifact on your machine as you have in your test environment and your production and all that, which you can do with, for instance, Docker or Podman or whatever floats your boat.
And probably it's worth mentioning here, sorry, is that we're mentioning Docker, we're mentioning Podman, but you can choose whatever you want. Standard container thing is pretty much standardized. There are different ways of running it. There is Rancher. There is a lot of ways of doing that. So it doesn't really matter. Whatever you want to run it on, you should be able to do that nowadays. At least you have quite a few options. It's not only Docker or only Podman or anything else. This is just a few examples. And one more thing that I want to mention is that containers, that means, typically I say that it means two things. It's reproducible builds, but it's also reproducible deployments. Because usually we talk about one of those things, and like typically it would be like, oh, but it's easy to deploy. So reproducible deployments is cool. But yes, it is. But it's also reproducible builds. You know that if it builds on one machine with the same kind of architecture and everything, it's most likely will be built in the same manner and similar way and other things. And you don't really have to build that. You just create a container image and just push it somewhere into cloud, and then you can just pull that image and deploy it in different environments, different servers, different machines, different things. All right, back to you. Sorry.
Yeah, no, but that's important input as well. And we could be talking about things like layered Docker file, like layered container files, layered images, and so on. And don't use, but I think someone else could do an entire talk on like building the best containers. So we won't talk much about that, but like please use things like use layers. Don't use small and tiny base images.
There is a lot of optimizations you can do with containers, and it's kind of important to think about that. It's not just shove things into a container, it's going to work, because you will need to do some optimizations. You will need to make sure that it takes less time for it to build. You want to make sure that you don't really use too much time rebuilding things that have been already so layered, like Mats mentioned, but also it's a good idea to keep your container size as small as possible for several reasons. So one is that you don't really need too much information, too much applications that are not really important for your code to be running there, for like security reasons, also space reasons. And also you want to have your container images to be as small as possible, because they will be pulled back and forth across the network at some point, and you want to make that thing as small as possible, so it goes as fast as possible from a container registry somewhere to a deployment machine somewhere else over the network.
I think,
one
more thing we should mention is
sure.
a shout out to the vendors that create the runtimes, is that often when you download the starter, we just talked about, you get a Docker file or two as an example, which you can use, and they typically follow the best practices we've been talking about now. So
that's actually a very good point. Yes. That's great to mention as well. So now we containerized it. I mean, like we said, it's not a very big surprise nowadays. Now everybody knows that we should put it in a container. Another kind of partially obvious, but maybe not so obvious thing is that you don't want to maybe be responsible for the whole ops part of that. So you don't really want to have your own servers. You don't want to, especially if you have a small, tiny little application, you don't really want to have a full server room full of racks and stuff and everything just around that tiny little applications. So one way of doing that is to push that thing into a cloud. It can be different kinds of clouds. I mean, public, private, hybrid, all these kind of things. But we're going to be mentioning or talking about public offerings that are available to everyone pretty much on the internet. So we need to, we have a container file, we have our code, we have it available through a REST API or URL, and we've put it into a container, and now we want to put it into the cloud and kind of beyond. We'll see what it means by what we mean by beyond in a little bit. But now we have basically a containerized application that is running there. What do we need to do to make our life much easier too? Because we want this thing to be just write code, commit code, and magically it's available. It's magically available, let's say, in some kind of public cloud offering, right? And well, first step would be to try to automate your builds, and that you definitely need that to be able to trigger builds out of the commits, but also you need to actually automate everything else as well. It's that by everything else I mean things like setting up your environments that does not exist maybe there to begin with. You don't want to put that into the same build procedure or pipeline, but you should probably have some kind of infrastructure as code set up for your environments. You should have automation for running tests on the new version of an application. You should have automation for checking the health of your application, checking how it's doing, how it's performing, if it needs to be restarted, and all those kind of things that will make your life much easier. If you deploy it to some kind of cloud, typically they will offer you a way of checking health of your applications and killing the containers that are not working, that are failing, respawning new containers that are working, and all those kind of things that will make your life easier. Also, they will offer a way of pulling the logs out of those containers and putting into the central place where all these logs will be. So you might want to automate some alarms or some alerts on some specific stuff for your application as well. But let's go back to build automation. So there are different ways of doing builds. Some of them are built in and follow the specific cloud provider that you want to use, and some of them are a bit more generic. So over to you again, Mats.
Yeah, so we started out by saying that our talk is a bit opinionated, and that we've chosen some tools. And when we were about to put the code and the builds and everything into a cloud, we needed to choose one of them. So for this talk, we've chosen Google Cloud Build and Google Cloud in general for running and building the code. It could be Azure, it could be whatever. But we chosen Google, so that's like the disclaimer. So what we see here is the user interface of Cloud Build, which is like Google's build service, as the name indicates pretty clearly. So you could compare it to like Jenkins or GitHub Actions or Azure DevOps, or all of these things are some of the same principles. But what you can see here is you can see the event on the screen, which is says like, when should this build be triggered? And it could, of course, do manual, but you can also say, whenever I push to branch main, do a build, or a pull push branch or whatever. So that's one of the important configs here. And the other important thing is the build configuration. You can see below it, where it says like, well, file type, you could say Cloud Build or Dockerfile, which are the options you have. And what we could say about this is that you choose one of them. So we already talked about the Dockerfile or containerizing. Like, so you can try to use the container you already created and like stick to that, or you could use more specific configuration in Cloud Build YAML. So Cloud Build YAML is it's similar to like GitHub Actions YAML files or Jenkins file. So each like build service provider has their own YAML format, it feels like. And what you could do is say that, well, I want to use some heavy lifting machines to do my build, or I want to do like some specific form of caching, or adding some environment variables, or anything specific to running in the cloud, in that cloud.
Yeah, because anytime you want to do something very specific that is, well, by specific, I mean specific for that particular cloud, you want to make it, you would like to put it into Cloud Build, the YAML or similar files like that, because Dockerfile contains information on how to build that particular container, but it doesn't say like, oh, I want to have so many cores to build that thing, or I want to build it in this way, or I want to integrate with some specific offerings or products on that specific cloud provider. So all those kind of things go into this specific build file that you want to put there. And again, if you choose Google Cloud, that's fine. If you choose anything else, you will probably look for similar build servers and build services like this as well. So now we've written code, we've put it into a container, we have deployed that image of that container into the cloud. And what do we do now? I mean, like, how do we run it? Because that's another thing, because when you go to any public cloud offering, and not only even public cloud offerings, all kind of cloud offerings, you will find several ways of running containers. So some of them will be, I mean, probably it will be anything from some kind of Kubernetes, managed Kubernetes offering to serverless offerings. So if you want to, or I mean, worst case, you can just go old school, really old school. You can just install a VM, install operating system, or create a VM, install operating system on a VM, put some kind of runtime on it, install that, and then deploy your jar files onto that thing. That's the probably least cloudy version of doing stuff. But you can do that if you have to, but you really don't want to do that, and you probably don't need full Kubernetes cluster to do that. there comes this part of and beyond, that we saw that to the cloud and beyond. And because you want to have as little management as possible, and that's where the serverless part comes in. So serverless is not really without servers, it's more like with less management. So it's manage less platform, or manage less offering, I usually call it. In our case, we're going to be using something called Cloud Run, which is started as a managed version of Knative some time ago, and kind of been developing in a little bit other ways after a while. But it's very similar to what you know as Knative, as an open source project. And it's traditionally it's been that in the bottom, there will be actually Kubernetes. You're not really running away from Kubernetes, but it's managed by somebody else. On top of that, there would be some kind of service mesh. Traditionally, it was Istio, but now you can also do different other ones. And on top of that, there will be a Knative running that can actually let you do that. So if you're going to go serverless on-prem on your own solution, you might want to go with just install Knative and make it all work. If you want to let somebody else manage that for you, then you can look for offerings like this. In this case, we're using Cloud Run to do that. And then there is also, even if you want to go even further, you can also go with like hybrid cloud offerings, where you will do between different like on-prem and public cloud, or multi-cloud, where you go between different cloud offerings from the public cloud providers. But with all that, there are offerings like that. There is also, for example, Anthos or OpenShift or things like that will let you do this kind of things across different environments as well. But still, it will be serverless. And serverless is kind of good because you're getting closer to this. I want to write my code, push the commit button, and magically it's deployed somewhere and runs, because you don't really have to do all the deployment thing. You don't really have to think about the health of your environments, more or less, and then it just appears there. And in our case, it looks like this. And the cool thing is that a lot of serverless offerings would also let you do some cool stuff. So, for example, by cool stuff, I kind of mean things like do traffic splitting. So, for example, you're deploying a new version, and you will say, hey, you know what? I'm not really sure about my new version. There might be bugs. There might be dragons. I want to have 5% of my traffic go to the new version and 95% go to the others, to the older version. And then so you can actually do traffic splitting and test and gradually increase the traffic and see if everything is good, and study your logs and study your metrics and all of that, and making sure that everything works before you switch entirely. It also lets you manage services like this, let you add quite seamlessly authentication on top of that, a bunch of other things that will make your application more kind of production, enterprise ready kind of things. There will be a lot of things that will help you with this. Anything else we need to mention when it comes to the environment?
I don't think so. Or I think we might say that when we come this far, you can see that we have done the entire process, so to say. So you can see at the top where we have green deployment.
And a lot of red ones.
We've been thinking about should we replace this image with one where we have been going for a while and had lots of green belts, but it's always this when you set up new build things. So
it's good to show that it's okay to fail, and we've been doing that. I mean, so that's the point, right? It will, especially in the beginning when you're setting things up and you're doing. Maybe in the beginning you will be doing actually quite a bit of click ops and just making things just deployed by with clicks and point and clicks and everything through the user interface of that cloud provider, and that will look like this. But at some point you should go from click ops to automated scripts and builds and pipelines and environment setup, and all that should be automated, and then you shouldn't see that much red things. I mean, unless something breaks in your code, your tests and things like that, right? But this is typically a first stage, so this is good. So now it runs, and then you can also notice that, I mean, it looks almost the same as you've seen before, but now you can actually see that the URL is different. So URL is actually public URL. It's one of the old URLs, so it's not really no point in trying to type that long URL and see if it works. We'll show you actually the working one in a little bit, but the whole point here is to actually tell you that now we have a public API. Now we're getting very close to make it available to everyone with least possible effort. We just run code, we deploy it, we've set up an environment, but we don't have to do all the kind of management of that environment in a sense, right? But we should probably talk a little bit about, because we talked about serverless and how amazing it is and all that, but it's not only just like, fun times and everything is just like happy day scenario. Sometimes you don't want to go serverless, or sometimes you might want to actually consider going a bit more other way. And like I said, there are different ways of doing that. There is when people talk about, first of all, when people talk about serverless, a lot of people would think about cloud functions or something like similar Lambda functions. It's being called different things, in different providers, but basically smallest units in quote out of serverless is a kind of a cloud is a serverless function, and that is not what we're talking about here. We're actually talking about the full application. But yes, you can do that. You can actually do serverless functions as well, but that should be very small, tiny little things that there is no point of creating huge applications, a lot of serverless functions talking to each other, because after a while you probably will lose control of all those, and it will be really hard to manage. So don't do that. But here we're talking about applications, and sometimes you want to, like I said, there is a lot of different ways. So the most kind of old school version of doing that is the installing a VM and putting everything. Maybe you want to do that, but there should be very specific reasons for that. So maybe it's an old application, maybe it's not really running, it has some specific requirements, it has some kind of hardware or other kind of requirements. But typically, next step from that would be at least like a few steps over that would be to put it on the Kubernetes cluster. But then you need to be able to, I mean, you can also manage the Kubernetes cluster yourself, or you can use the managed services of that. But in that case, you will need to have an actual application with quite enough of users, quite enough of load, quite enough of containers for it to be worth running that. Because most of the people, most of the applications don't really need the whole huge multi-node Kubernetes clusters and stuff like that. There is also also other ways of running applications that are more permanent, in a way that it will not scale down to zero. I know that Cloud Run offers now ability to scale down to 1, not 0, because in case you don't want to do that as well. But still, if you go serverless, you have to be prepared that technically your application can be killed and recreated without any user noticing that change. And that means that kind of brings a few requirements to that. So most of the cases, you should have a serverless application that is stateless. So that means that you do not store any state in that container. It has a database, it has a storage and everything in somewhere else, in a different different container, different environment, different place, that all the containers can actually access and can be killed and restarted without losing any data or having to reload and do things. Well, loading data is fine. Losing that data is bad. So yeah, so there are different ways of running it, but make sure that if you go serverless, you want to make sure that it's probably stateless. And also, if you have an application that is very heavy on startup time, on loading stuff from the database or wherever it's loading data from, if it has a long time, so if it's a large containers that take a long time to actually pull over the network, probably not a good idea to go serverless. If you have very tiny little container that's really fast, but your application inside there takes some time to load, probably again not a good idea to go serverless, because users will spend a lot of time in waiting for that thing to load, and for them it will be looking like the application is slow, unresponsive, laggy, and all these kind of things, at least in the beginning, at least the cold starts, what you call like the first start of application, first call coming in to the application from it just starting up. So, use this. Serverless is not a solution for everything, but it's a solution for a lot of things. But, there are some options where you don't want to do that. And speaking about performance and all these kind of things, it still needs to, even if you go serverless, even if your application is fast enough and all these things, you still have to try to optimize build of your containers, first of all, but that's not as important as actually load of your containers as fast as possible. So you need to optimize that. Make sure that the size of container is small. Make sure that you can, the first startup your application is fast. And then maybe if you need more data and stuff like that, maybe you can lazy load that later. But make sure that, the point is, make sure that your users do not experience a lag when they're starting, when the first call comes in. And that's all on the containers level, applications level, and all that. But there is also another important part of that, and that is that the runtimes you're using to run your application inside that container can also differ. So you can actually, they would have a little bit different startup times. They will be especially tuned in for specific things or specific use cases and stuff like that. And like we said, we've mentioned that already a few times, both Jakarta and MicroProfile, they are specifications. It's up to the providers to actually implement those. And they will be implemented in a tiny little bit different ways, meaning that performance might be different. So that's a good thing to keep in mind as well. And the one we're actually going to be talking here about is Quarkus that we want to mention. As you can probably have seen it already from the title, we will be mentioning Quarkus. And we do that because it has a specific, it is really quick to start up. So it fits really well into the whole this serverless story that we have. And also because it actually have even further, it has two different modes for doing things. And we'll talk a little bit about that as well. So it's there is a JVM mode that lets you do it in to start your application as a general, like a JVM mode JVM application, but also it has a native mode where everything goes compiled down to binary, and then you can just start it up as well. Before we do that, maybe we should talk a little bit about how to migrate to Quarkus. So, I mean, if you're running on something else, how do I switch to Quarkus?
Yeah, and what's really cool about this is you can see a list here, right? That's like check. And you can see, well, you change POM files to create check properties files and YAML files. What you don't see here is anything of your Java or Kotlin code. So you don't need to change the code at all to switch from another Jakarta and MicroProfile compliant runtime into Quarkus, or the other way around for that sense. So you get really portable code in that sense. But I think maybe we should mention as well, like why Quarkus, or like why Quarkus, yeah, and it has a really fast startup time. That's one of the characteristics, and it can do that because Quarkus is made to be run inside a container. That means that most Java runtimes they do quite a lot of stuff to like support drop-ins or config changes or so on during runtime. Like as the application is running, files can drop in from outside, or new beans can be added, or so on. But with Quarkus, Red Hat said that while nowadays we are running inside a container anyway, that means that the environment is stable and it's set. So that won't actually happen, and that means we don't need that support. And that again means that you don't need to do those checks when the runtime is starting up, which means faster startup time. And yeah, so yeah, we could talk lots more about Quarkus. I guess Kevin in the chat can answer something as well. He's working in Red Hat, but here we are with Quarkus, running application in Quarkus, and you see the response is pretty much the same. But what you don't see is that this answer came much faster than the previous one.
Yeah, and we'll see that. Well, if we have, I think we'll have a little bit of time at the end, so we can actually show you a cold start for Quarkus and all these kind of things. But we have one thing that I kind of mentioned. I did mention it as a little bit as already, but we have another thing that we want to. How do we make things? I mean, now we put a Quarkus and it starts really fast in a JVM mode and everything is cool and everything. How do we make things even faster? Well, except for adding another racing car emoji to the slide. What do we do? Well, that. So you want to talk a little bit more about the native mode, Mats?
Yeah.
Or you want me to do that? Well, do that. Go ahead.
I can go on for a long time. I'm trying to do the short version. Like you can, as Rustam said, you can do Quarkus in JVM mode, or you can do it in native mode. And in native mode, you use GraalVM. And it says that, well, we don't actually need the JVM, so let's run it as a binary, which is that is smaller and it starts up crazy fast. So it's for settings like this where like the scale up time from 0 to 1 is really important. GraalVM is the thing to go to, and it's really emphasized by Oracle nowadays. Is it looks like GraalVM is kind of the primary focus. So it's getting better and better.
And the thing that's worth mentioning here is like the different modes they have there. I mean, if you're creating an application like ours that is kind of simple and not that many users expected to be there, it's not super like production critical or like business critical application, all this, that's cool. Then you don't really have to think about those things. But if you have a very specific kind of environment and specific requirements to your application, then you need to think about that different environments, different modes will have a tiny little bit different optimizations for things, right? So with JVM mode, you will see that JVM is doing some smartness and actually optimizing calls. So in the beginning, they might be a little bit slower, and then they will kind of learn and become a little bit faster with time, because JVM will do some kind of optimizations, garbage collections, memory optimization, all these kind of things in the background. With the binary mode, they don't have that. So then you will have much more linear, but maybe a little bit slower response time. But now we're talking about milliseconds of that. So like I said, your regular application won't mention that, won't notice that. If you're doing super crazy performance optimized trading application that needs to do like every microsecond counts and everything, then you need to think about issues like this. But in general, you don't really need to think about that. But yes.
Yeah, I guess there are a few other things we should mention as well. The first one is a shout out to Red Hat for the documentation on Quarkus native. It's getting better and better, and now it's really good. So like if you Google Quarkus native and get into the Quarkus documentation, you can find most things you need there. And the other thing is like building an application with GraalVM is heavy. It's heavy, a lot of heavy lifting, like creating the native file. So that means that your build is going to take longer, but you win. So you trade build time for runtime.
And I mean, you don't really care, right? I mean, if builds are happening in the background, your application is still, if you have already an application or a build is happening in the background, your users won't see anything different, right? So it's fine to actually to sacrifice a build time, because nobody is, except for us developers just waiting for build to finish, nobody really kind of sees that part, right? But they see the startup, they see performance, they see all this thing once your application is running. And so now we have a different kind of URLs, right? Now we have a Quarkus one, and then we have a native one. Again, those URLs, don't try to type them. There is no point in trying to do that, because they're wrong on purpose, but or older versions of that. But we'll show you the live one in a little bit in a second. And now we are kind of getting to the end of the story, right? We started our story with writing a little bit of logic. We added a little bit more to it, or actually quite a bit more to it, in the form of Jakarta E and MicroProfile and all that, to make it available through the web interface, which is all, well, more or less all modern applications are expected to have an interface through. And then we containerized it. We also found a way to deploy it with less toil. So we chose to deploy it to the cloud. It could have been your own cloud, but we ended up on a public cloud. And then we also talked about how to make it less, also actually less expensive, because it's if you go serverless, it will cost you less because you don't only pay for the time your application is actually up and running and not all the other times. So if your application has less users, less load, it's a good thing to have this thing scale down to zero thing. But it has some disadvantages as well. Don't try to chase this scale down to zero thing if you don't have to again, but it's a good idea as well. That's pretty much it. So now we have a serverless application. We talked also a little bit about when not to go serverless and what you can do to make your serverless applications even faster. All of this is so both Quarkus multi-stage builds and also all the application code for the MicroProfile random strings. So this tiny little application with all the build files and all this, everything is available in GitHub. So feel free to take screenshot of those two links here and follow those. We have another thing that you can take screenshot. This is us on social media. So this is our links on Twitter. But you should be able to find us as well with the name, with the same name, or maybe a little bit different handle, at least for me, on different other platforms as well. Mastodon, Blue Sky, whatever is out there, probably you'll find us there as well. So that's another one last thing. And now I think we can do a really quick switch back to switch the screens and show a little bit of a demo before we do the any comments or questions or anything. I've been looking at the chat. There is nothing coming in yet, but if there is anything, if you have any comments or questions or any other things related to cloud native applications or Java or anything like that, feel free to write into the chat while we're doing the demo. So I will stop sharing. Thanks a lot, Carlos. That's really nice. Okay, I'll stop sharing here, and then you can take over. Mats, let me do this. Yep. Stop sharing. Take it away.
And while I start sharing, I can also say that, well, please ask questions in the chat if you have anything, and I will also post those slides at the meetup page or somewhere. I guess Serena can help us with that afterwards. So you'll have everything done. So what you can see here now is Google Cloud Run. This is live, so this is real stuff. And you can see you have random string Quarkus and you have Quarkus native. So when we say that things are fast, what does that really mean? So let's copy the URL. So what you can see now is that the application is stopped. No instance is running. I haven't done anything in hours. So now I'm typing the URL. And this is the JVM mode Quarkus. So when I press enter now, you can see that the container is starting, Quarkus is starting, and the application is starting. So let's see how long.
Tell us when you actually pressed enter, just so because we don't see that.
Yeah. So I press now.
Yes. 2.
Yes.
3.
As a user, I'm going to be impatient 5. By now.
Yeah. There you go.
Reachable device. Okay. So that's with the JVM mode. It takes some seconds. So let's head over to the native one. I'll copy the URL. You can see also here that it's not running. Totally.
Yeah, it scales down to 0. So that's actually pretty cool. All right.
So now I'm starting.
When?
No, yeah, here we are.
Less than a second.
This is like, as a user, I'm not getting impatient before getting the answer when running native mode, which is really cool. This is Java code. It's getting up from 0 to providing an answer to the user in such a fast time. Really cool.
And you have to think. I mean, it might sound. I mean, for some of you, it probably sounds impressive already. But if if you think about what actually is happening, how many things are actually happening in the background, it becomes even more impressive in a way, because here I didn't manage to even count to 1, right? So it's like less than a second. The other one I managed to count to like 5, maybe something around 5 seconds. And that is really, 5 seconds is fast, but less than a second, it's even faster. I don't know if my calculations were correct, but we can see it very soon in the logs.
Yeah, about a second.
Yeah, exactly. And the thing is, think about what actually happens in the background. As something has to wake up and receive that HTTP request, try to figure out where is that supposed to go. Go to the container registry, pull that container image, put it onto, find a place for it to run, start it up, the container, starting up the OS operating system or whatever the layer is in a container. Then that thing needs to start up the application itself. And then it has to actually process that URL request, that HTTP request, and send it back to the user. So there is quite a lot of things that are happening in the background that we don't really think about when we want to see. And me as a user, that 5 seconds versus 1 second is a kind of different thing, because for the other one, 5 seconds is not that bad, but I will probably realize that, oh, this thing is probably starting up now. With the other one, I wouldn't really know if it's running already, if it's warm and pre-warmed up, or it's just a cold start. I would probably not have a chance to actually know that. So that's really, really nice. Any questions? Any comments? I still see nothing in the. Yeah.
Well, thank you very much for that excellent presentation, team. It was great and very well received from the audience. We don't have any questions, but I do want to take a few moments to quickly wrap things up here. So we are always looking for more Jakarta Tech Talks through 2023. So the fall season, and we're just halfway through booking our last presentation. So if you're interested, feel free to fill out the form that I linked in the chat a few moments ago. And of course, your feedback of the Tech Talk program is greatly appreciated. So once we close out this webinar session, there's going to be a little green button that will pop up. Please let us know how you enjoyed the talk. So thank you again, Mads and Rustam, for an amazing presentation. And you guys have a wonderful day.
Thank you for having us.
Thank you.
Thank
Take
you
care.
all for joining us. Bye-bye.
Thanks. Bye.